Okay. So in our previous class, we have learned about the properties of carbon. Okay, the properties of carbon by which they can form a so large number of compounds. And we learned that because of their covalent property and because of their catenation property and their small size, organic compounds can form a large number of compounds. And when carbon and hydrogen are from compounds, okay, that compounds are known as organic compounds. So here you can see, okay, here you can see carbon is known for its catenation property. Yes, catenation means self-combining property. Carbon has a unique self-combination property. The covalently bonded carbon containing compounds called organic compounds are substantial for life on Earth. Yes. Okay, so the carbon compounds, the organic compounds are mainly covalently bond, and because of the formation of this covalent bond, okay, they form compounds which are life-saving, which are important for life. The specific branch of science that deals with these organic compounds are called organic chemistry. Okay, organic chemistry encompasses every characteristic feature of an organic compound. So that means organic chemistry actually deals with each and every characteristic, each and every features of various organic compounds, their properties, their behavior, okay, their properties, their behavior, and how they react in different conditions. Okay, so that is actually organic chemistry. So why do we learn organic chemistry? Because organic chemistry gives us idea that how organic compounds react, how organic compounds are behaved, how organic compounds are formed, various type of compounds. So these are the things we have to learn. As well as we have to learn their characteristics, their various properties. So these are the things we will learn detail in organic chemistry. In class 11 and 12, you just learn the basic things, and in higher classes, you will learn in details. Okay, it is a very vast syllabus it have, organic chemistry. Now we will going to discuss the structural representation of organic compounds. We will going to discuss now the structural representation of organic compounds. Okay, structural representation of organic compounds or molecules. Okay. Though organic compounds has only one chemical formula, structurally it can be dissipated in numerous ways. The first one is complete structure, second one is condensed structure, and third one is bond line structure. So we can actually represent an organic compound mainly in three ways. One is complete structure, another is condensed structure, and another is bond line structure. Complete, condensed, and bond line structure. Now we will learn in detail that what are the complete structure or what are the condensed structure and bond line structure. Okay. So complete structure, see what is complete structure. The Lewis dot structure is considered as complete structure in formula. Okay. In Lewis structure, the covalent bond in the compounds are donated by the dash. Okay. So that means we can see what are the complete structure. See, complete structure. Complete structure. Just a second. We number one to join. This one. Okay. So complete structure. So if I see if when we express it by this dash, by the using of this dash. So what is it? This is CH3, CH3. CH3, CH3 means ethane. So this is the complete structure. Okay, this is complete structure. See, this helps to emphasize the number of bonds formed by the electrons. So that means from complete structure we can understand the number of bonds formed by the electrons. Every single bond, a double bond and triple bond are represented by one dash, double dash and triple dash. Yes, so if there is single bond, it's one dash. If there is double bond, you know that there is two dash. And if there is triple bond, there will be three dash. Okay. It illustrates every single bonds formed between every atom and the compounds and called complete structural formula. Is known as complete structural formula, is also known as dash formula. Okay, is known as complete structural formula, or is also known as dashed formula. Okay, see here, ethane, then ethene, then ethyne, how they express. If all the bonds are clear, carbon are forming 4 bonds and hydrogen are forming single bonds. Everything is clear. Here see double bond, here is triple bond. This carbon is bonded with one hydrogen. This carbon is bonded with 3 hydrogen. Then this carbon 3 hydrogen, and they form bond between them. Okay, so that means each and everything is clear over here. Understood? Clear?
Yes, ma'am.
Till this much clear? Very easy.
Yes, ma'am.
Okay. Now, condensed structure formula. Since complete structure formula consumes much time and space to represent, yes or no? If we have to show all the bonds, it will take much time as well as it will take much space also. Ethane, ethene, ethyne, they are very small compounds. But if we consider the large compound, suppose and then methanol, suppose then butanol or propanol. Okay, so it will take a huge time. Propanol will be 5 carbon, 1, 2, 3. So 3 carbon. 1, 2, 3. This is propanol. Okay. In this way, we have to write. So it will take much time. It will take much time, and it will take the space also for the structural representation. Yes or no, boys? So if there is, suppose butanol. Butanol means here we have to add 1 more carbon. See, this is butanol. If we want to write pentanol, then 1 more carbon I have to add. Right? So structure become huge. It will take time as well as it will take space also. Okay. So we can condense them, and this is condensed structural formula by replacing some dash bonds by the number of identical groups attached by atom by a subscript. See, like this. We can write ethene like this, ethane, CH3, CH3. Then ethene will be CH2, CH2, and ethyne will be this one. We can represent them like this. We can represent them like this. Yes or no?
Yes, ma'am.
Okay. And the last one is bond line structural formula. This is the last one. A bond line structural formula is another way of structural representation of organic compounds. Okay. And here, every bond is represented as a line in a zigzag manner. If not specified, every terminal is assumed to be a methyl group. Okay. So see, if we say ethane, CH3CH2, it will be represented like this, CH3CH3. If there is propanol, or sorry, propane, it's ethane propane. Suppose propane, this is CH3, CH2, CH3. So it will be like this. Okay, it will be like, no, not like this. Sorry, just a second. So for ethane, okay, for ethane, it will be like this, just a single line. One carbon atom over here, one carbon atom over here. Okay, for propane, CH3, CH2, CH3. For propane, it will be like this, one carbon atom over here, one over here, one over here. It has 3 hydrogen. It also has 3 hydrogen. It has 2 hydrogen, like this. Okay, and if it is like this, so this carbon will be the number 1 carbon, this is number 2 carbon, this will be number 3, number 4, number 5 carbon. Let's take few examples. Let's take few examples like CH3, CH2, CH3, OH. CH3, CH2, CH3, OH. Okay. So how we can represent this one? How many carbon atom? 1, 2, 3. Here is 1, 2, 3. 3 carbon atom. With the third carbon atom, OH is with the third carbon atom, OH is attached. Okay. Just like next is suppose CH3, CH, Cl, CH2, CH3. Then how many carbon atom is there? 1, 2, 3, 4. 4 carbon atom. So 1, 2, 3, 4. And carbon is attached with second carbon, chlorine is attached with second carbon atom. So there will be chlorine. Now next see this one, CH3, CHOH, CH3. Okay. How many carbon atom are here? In this molecule, how many carbon atom are here?
3.
So 1, 2, 3. Okay. So 1, 2, 3. And with the second carbon atom, OH is attached. So this one. Okay. Till this much understood? Any confusion?
No, miss.
Okay. And next we will do what we will do, that is the 3D formula. See, 3D representation of organic compounds that we have to learn right now. Just a second. So in organic compound, which are represented using structural formula, okay, there are 3-dimensional, some compounds are 3-dimensional. That means in case of that, suppose 2 bonds are in plane and a second bond is not in plane, the second bond or third bond will be in out of plane. So in order to draw 3D structure of an organic compounds, we can use wedge at dash representation. See. So this is the methane. So these two hydrogen atom, okay, these two hydrogen atom are in plane. These two hydrogen atom are in plane. Okay. This dark one, this one. Okay. This solid one is this solid wedge. This is bonds towards observer. See here, you can understand. So this bond is towards who I can see. You are seeing the bond now. So this bond is towards you. And this is actually this dot. See this line. This line is actually known as dashed wedge. Okay. And this bond away from observer. Okay, understood? So in methane, there are 4 bonds. These 2 bond is in plane. Okay. The solid wedge is represent the bonds towards the observer. That means towards us. Actually, we are seeing the compound. Okay. And the dashed wedge is just the bond which are away from the observer. That means you can see, if you see the compound, see this one, that means it is behind the compound. This bond is behind the compound. This bond is towards you. And these 2 bonds is actually in plane. Clear? If we see this structure, see, in this structure, these 2 bond in plane? Yes or no? These 2 bond is plane. This bond is towards you, above the plane. We can say this is above the plane. And this is being an observer. This bond is away from you. Yes or no? Tell me, understood or not?
Yes,
Yes,
yes
or no?
ma'am. Yes.
So this is actually the 3D representation of bonds. 3D representation of organic compounds. Okay. Till this much, do anyone have any confusion? If you have any confusion, you can ask me right now.
No, miss, no confusion.
Okay. So now we will solve few problems. Like, I'm writing one condensed formula. CH3, CH2, CO, CH2, CH3, CH3, CH2, CO, CH2, CH3. Now we have to write down its dashed formula, okay, or structural formula, complete structural formula we have to write. So, see, it will be carbon. Carbon are containing 3 hydrogen. Okay. Two hydrogen here. Here is 1 carbon. See, it bonds with 3. So clear the structural representation. Understood?
Yes, miss.
Yes, ma'am.
Okay. Now next. Now, The next compound, this is the condensed formula CH3, CH, double bond CH, CH2, whole thighs, CH3. So how? First, this carbon is bonded with this carbon. So obviously single bond. This carbon is bonded with 3 hydrogen. So 3 hydrogen are like this. This carbon is bonded with 1 hydrogen because a double bond is formed by this carbon. And then here CH2 whole 3. That means 3 carbon will be there. Each carbon bonded with 2 hydrogen.
To total 6.
Yeah. Then this is the dash line formula. Clear? This is the dash formula, structural formula. Yes or no?
Yes, ma'am.
Okay. Now next. Now next is,
Ma'am,
say,
for midterm, we will not have this chapter, no?
no.
Okay.
Now next is this formula. CH, CH3, CH, CH3, CH3. So for that you have to write, for this compound, you have to write condensed formula as well as bond line formula. So for condensed formula, what we have to do, see, first this one is, how many CH2 is there? 1, 2, 3. 3 CH2 is there. So we can write this one CH3 whole 3. Sorry, CH2 whole 3. It will be CH2. Sorry. Yeah, CH2 whole 3. Then CH, this one we will write. Then this CH3. Then this one is there. Then how many CH2 are there? 1, 2. So we can write this one CH3 whole 2. See, we can represent the above formula like this or not.
Yes, ma'am.
Okay. Now the bond line formula, yes. How many carbon atom are there? First we have to find out. 3. Okay. How many carbon atom are there in long chain? That we have to first find out. Okay. From this compound, 1, 2, 3, 1, 2, 3, 4, 5, 6. 5, 6. We will not consider it from here. We will consider the main formula. So 6 carbon atom in there. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes. Now OH is present with first carbon. So OH will be here. Now see, with fourth carbon, see this one, with fourth carbon, 1 methyl is there. So we can say that this will be the methyl. And now for sixth carbon, see, this is sixth carbon. With sixth carbon also, see, sixth carbon, 1 methyl is there. So we can write it like this. Yes or no? No, I have done a mistake. Just a second. Sorry, I have done a mistake. 6 carbon, 1, 2, 3, 4, 5. See, this is 1, this is 2, this is 3, 4, 5, 6. Aditya want to join now. So here OH is added. And with that, with 4th carbon atom, 1 methyl. And with 6th carbon atom, C, 1 methyl is also there. So this is actually the bond line formula. Clear? Understood? Okay, so we are moving to the next one. Next one, the structure is this is the structure. Okay, now condensed formula will be like this. HO, CH, HO, CH, CN whole 2. This is the condensed formula, and the structural formula is like this. Bond line formula like this. Understood? Any confusion?
No, miss.
Okay, so in our next class, we will solve this type of problem once. Then we will going to learn tomorrow. We will learn the classification of organic compounds. Okay. So I'm ending the class now. Thank you, everyone. Have a nice day. Thank you, everyone.
Thank you, ma'am.